So for all of these movies, I've plotted them as individual points. Each movie is one individual point. Each movie represents the budget amount against the amount that it grossed. Now, by looking at the overall pattern, I could determine whether or not, at least subjectively, whether there's an association between the budget and the gross. If I'm in the movie industry, I'd like it so that I could predict what the gross would be based on how much the budget is. I'd like to know that if I put up $100 million for a movie, I'd like to have a pretty good sense of what the gross is predicted to be. Now, these points are not all that close together, so the prediction isn't all that accurate. If they were much closer to a straight line, then the prediction would become much easier. But I do see an overall pattern going from lower left to upper right. And this graph tells me a story. It says, as I tend to spend more on a movie budget, as I put more money into the movie, I'm more likely to get more money back. And that would make common sense. And that seems to be the way it's working in general. Now, to illustrate how easy it is to get a scatter plot, I'm going to go to my computer. I've got StatDisk loaded up. I'm going to go to Datasets. And I'm going to go down to Movies. Let's see, where are Movies? Right there. And Budget is column 3. The amount of gross is column 4. So I just click on Data. One of the topics is Scatter Plot. For X, I'm going to pick the budget. And if I don't remember what they are, I could just slide the screen down a little bit. I can pick the budget for column 3, the gross for column 4. Click Plot. I'll move that up a bit more. And there's a nice scatter plot. Okay, there's the same scatter plot that we just looked at. And look at how quickly I could generate that in StatDisk. Really, really easy. I can include the line or not include it. I could even plot it. I could print it if I'd like. I could save it. I could export it to a document. But super easy to get. So graphs don't have to be very difficult if you use the correct technology. Now I'm going to shift over to a time series plot. Okay, in a time series plot, we have one variable, but we're looking at the variable in terms of what happens to it over time. Here, these numbers are somewhat small. You really can't see them well, but they're years, starting with 1980, 1981, and so forth. And then the vertical axis represents U.S. motor vehicle deaths. So in this period from 1980 to 2000, I tend to see a pattern of a decrease in motor vehicle deaths. And that's good. That's something I would like to see happen. Fewer people die in motor vehicle deaths. And so I might question, why did it happen? What are the reasons for that change? What are the reasons for that pattern over time? I might think about the fact that seatbelt rules were implemented, mandating uses of seatbelts. Airbags are installed in cars typically now. Stricter drinking and driving regulations. Cars are better built. There are mandated requirements for child seats in cars. A number of different reasons that could explain this. But I do see the pattern, and the time series plot is an excellent way to illustrate that. Now, this section covers a variety of specific different topics, but in many cases, you have to be extremely creative, and you might construct a graph that's totally original, something that's never been done before. Let's take a look at this. This appeared, I think it was the New York Times. They took 6 Academy Award ceremonies. They recorded all of the words that were spoken at the ceremonies, and they printed the words in proportion to how often they were used. So look at how often this word thank was used at the Academy Awards compared to other words like, the word award itself, relatively infrequently. I thought that this was a good example of a graph that's very creative. Here's another one. A couple of years ago, I wanted to buy a sport utility vehicle. I live in a region of the country where we get a fair amount of snow. I've got a long driveway. I need a four-wheel drive vehicle to be able to get up and down my driveway. I was considering a Jeep Grand Cherokee or a Nissan Pathfinder. Now, this is basically from Consumers Reports magazine. They collect results from car drivers, and they've developed this excellent way to illustrate information about the cars. Here we have engine. Now, red is good. The red with the little hollow dot in the middle, that's about the best. Solid black would be the worst. Okay, here's the best, here's the worst. And then I have these different categories: engine, cooling, fuel, ignition, transmission, electrical, air conditioning, suspension, brakes, exhaust, the paint, the trim, the rust, the body integrity, the power equipment, and the body hardware. A lot of variables, but they've come up with this scheme for illustrating on them in a way that's very effective. And just by comparing the last year that I have of the Nissan Pathfinder, all this red tells me that that's a high quality car. And over here, well, the Jeep Cherokee, pretty high quality, not quite as high. A couple of cases where the dots aren't quite as solid. And historically, more black here than you see here. So more red, less red. More black, less black. This indicates to me that overall, the Nissan Pathfinder has traditionally been historically a better quality car. So I ended up buying the Nissan Pathfinder. If any of you are considering buying a used car or a new car, you can go to Consumer Reports and get graphs just like this for the cars that you might be considering. An excellent piece of information to have available. So, in this segment then, what's the objective? It's not necessarily to master all the details of manually creating every one of the types of different graphs included in this section, but it's to develop a sense for the concept that we should be able to create a graph that is effective in revealing the true nature of the data. What graph does that best? That's the one that we'd like to work with. And there are a couple of different graphs in this section that are quite important that we should really know quite well. We're going to come back to the scatter plot when correlation is discussed later on in the course, for example. And histograms discussed in the preceding section, really important. But keep in mind that ultimate objective. How can we develop a graph that conveys the true nature of the data? That's what we want to do. So that concludes this segment. Good luck with your homework and good luck on your next test. Thank you.